We're talking about exponents, and remember from before, this column is going to represent what's happening in the base of your exponential, and this column represents what's happening in the exponent of your exponential. And these two things are related in that they're always one step down as you move from the base to the exponent. So if you have an exponent being raised to another exponent, that means you're going to multiply or divide those exponents. If you have things of the same base that are being multiplied or divided, that means you're going to add or subtract the exponents. And if you have things of the same base that are being added or subtracted, that means that you're going to do nothing with the exponents. And it's important to remember that you have to have the same base. If you don't have the same base, then you're not going to combine them anyways. Nothing special is going to happen with the exponents because they're not going to combine together. Okay, so it's this last relationship here that we're going to be paying attention to for now. So let's look at some examples. Okay, so 2x plus x. When you add or subtract things that have the same base, that means you do nothing with the exponent, right? So you have 2 copies of x, and a single copy of x is going to give you a total of 3 copies of x. Not 3x squared. So a common mistake is for some students to see x plus x and think that means x squared. It doesn't. When you're adding things with the same base, the exponent stays the same. Since this was an x and this was an x, this is also just an x. Not x squared, not x cubed. Speaking of x squared and x cubed, how about this one? X squared plus x cubed. So remember, we're adding or subtracting things here, which means that the exponents do not change. So that means that since we had an x squared to begin with, we're going to keep an x squared. And since we had an x cubed to begin with, we're going to keep an x cubed. So nothing about this can be simplified. Okay, this just stays as it is because you're not supposed to change the exponents. And since the exponents don't match exactly, we can't combine them like we did in the first example. Okay, so let's try and do this one. 3x to the fourth minus 5x to the fourth. Again, we're adding or subtracting terms that have the same base. X is the base in all of these examples. So you have 3 copies of x to the fourth minus 5 copies of x to the fourth. Well, we know since we're adding or subtracting, we're going to get something that has x to the fourth because the exponent is not supposed to change when you're just adding or subtracting things with the same base. So if you have 3 minus 5, that gives you negative 2 copies of x to the fourth. So this is an example of how you add or subtract things that have the same base. And remember that when you add or subtract in the base, that means that you do nothing in the exponents. If you saw an x in the original, you better have an x in the answer. If you saw an x squared and an x cubed in the original, you better have an x squared and an x cubed in the answer. If you have an x fourth in the original, you're going to have an x fourth in the answer. Remember that when you add or subtract, that means just do nothing to the exponents.